This is question 7 from the SACE Stage 2 Physics course companion from chapter 1.4 Relativity. Here we have a pion moving at a speed of 2.8 times 10 to the power of 8 meters per second, and in the frame of reference where it's moving, it has a lifetime of 2.6 times 10 to the power of minus 8 seconds. First, we need to determine the distance travelled by the pion as measured by our stationary observer, so that's the same time that we just have in the question. So for part A, we're just using the simple relationship, distance is speed times time. We have the speed as 2.8 times 10 to the power of 8 multiplied by the time, which is given in the question as well, 2.6 times 10 to the power of minus 8 seconds, and if we substitute that into our calculator, we get 7.28 meters, so that's not too bad. Next, we need to work out the Lorentz factor for the pion. So here we're using our relationship 1 on the square root of 1 take v squared over c squared. This one's a little annoying to write out since we don't have it in terms of c. You can put it in terms of c, but I think we'll find it's not too bad. So 1 on the square root of 1 take 2.8 times 10 to the power of 8 over 3 times 10 to the power of 8 squared. Now we have the two 10 to the power of 8 scale factors in our expression, so we can just get rid of those. And now it just becomes 1 take 2.8 over 3 all squared. And if we substitute that into our calculator, we get 2.79. Part C requires us to work out the lifetime of the pion in the frame of reference of the pion. So here we need to work out T0, so we're using the relationship T equals Lorentz factor times T0. We're after the time measured in the frame of reference where the coordinates are fixed, so that's the frame of reference of the pion. So here T equals T on gamma. Let's get rid of that one. And now it's just a matter of substituting in the values that we have. So from the question before, we have the time t is 2.6 times 10 to the power of minus 8. And we've just calculated the Lorentz factor as, it's a bit messy, as 2.79. And if we substitute that into our calculator, we will get 9.33 times 10 to the power of minus 9 seconds. Finally, we need to determine the distance travelled by the pion as measured in the frame of reference of the pion. So in a similar way that we did on the earlier questions, distance is speed times time, except for in this case we're using the time as measured in the frame of reference of the pion, so the 9.33 times 10 to the power of minus 9. And so our value will be 2.8 times 10 to the power of 8 multiplied by 9.33 times 10 to the power of minus 9. And if we substitute that into our calculator, we should get 2.61 meters. So that wasn't so bad. The hardest part was probably working out the Lorentz factor, but after that, the rest of the algebra is fairly simple. The substitution is fairly simple. Yeah, like most of these questions, the hardest part is working out which frame of reference is, which time is measured by which frame of reference. A nice little trick is, just the way to make sure that you're getting it correct, is that because the relationship is t equals gamma t naught, your value for t is always going to be larger than your value for t naught, because you're multiplying it by the Lorentz factor, and that's always either going to be equal to 1, so it'll be the same value, which makes it not even a proper, it's just a trivial relativity question, but otherwise the value of t will always be greater than t naught. So if you're not sure which one's which, that's a nice way just to confirm that you've got the right answer. And that's it.